Good evening, ma'am.
Good evening, Atika.
Good evening, ma'am.
Very good evening, seventh class.
Good evening. Good evening, ma'am. Good evening, ma'am.
Good evening. Put on your cameras, please. Did you find out the application of concave mirror or convex mirror?
Yes, ma'am.
Okay.
Yes, ma'am.
8 students are there. 15 more to join. Okay, let's begin with a recapitulation. Hold on. Sriyansh, what do you mean by lateral inversion? First of all, please everyone come on the camera. Quick, very quick. Come on the camera, please. All of you. Manas, Rohini, Sriyansh. Yeah. What do you mean by lateral inversion? Sritij?
Ma'am, lateral inversion is basically a horizontal inversion by a plane mirror.
Okay. Sriyansh, tell me any 3 characteristics of image formed by a plane mirror except lateral inversion. Any 3 characteristics? Quickly.
Ma'am, can you repeat the question?
State any 3 characteristics of image obtained by plane mirror except lateral inversion.
Ma'am, can you give me a minute? I'll get my notebook.
Pardon, please.
Ma'am, can you give me a minute? Like, I'll go and get my notebook.
Yeah, sure, please. Sriyansh, this question was for you. Sriyansh.
Good evening, ma'am.
Good evening. Children, see if your name is called upon, you are supposed to unmute and answer. Say anything you know about this, in characteristics of image. Don't stay muted. This way you will not grow, means how will you evaluate that you have understood, you have learned or not?
Ma'am, can I say?
No, Siddhant. Divesh,
Yes, ma'am.
Please tell the answer.
Ma'am, can you repeat the question?
Listen the question carefully, everyone, okay? Three characteristics of image obtained by plane mirror, except lateral inversion.
Okay, ma'am. Ma'am, ma'am, it's the same distance from the mirror, and it is erect,
Okay,
and the image is virtual image.
very good. Great. Next is okay. Now, I gave you the homework to find out the applications of spherical mirror. So, the names I'll call, okay, you only have to tell any one application of any mirror. Rohini. Rohini, where have you seen the spherical mirror? Be quick in answering, okay? We do not have time to waste. So I think I need to write the names now, na? Those who do not unmute themselves and do not answer. Adrit?
Yes, ma'am.
Ma'am,
Yeah.
ma'am, you're told to find the applications of concave and convex mirror, right?
These two together are known as spherical mirror. So you can tell any one application of any mirror.
Ma'am, the spoon, the inside of the spoon.
Oh, this I only told you, isn't it?
Then, ma'am, like a bowl inside and outside of the bowl.
Can be, yeah. Adrit, keep your answers ready in your mind. Adrit,
Can you repeat? I mean, like your voice is breaking for me.
you're not audible, dear.
Ma'am, like, can you repeat the question?
Can anyone hear what is the?
Ma'am is saying he wants you to repeat the question.
We are discussing about the application or uses of spherical mirror. So tell anyone.
Ma'am, like they are used in ma'am, are they used in telescopes?
Telescope, very good, great. Ashwat,
Yes, ma'am.
Hmm.
Ma'am, like I was absent last 2 class.
children, please speak loudly.
Ma'am, I was absent last 2 classes.
Okay. Ashwarya,
Yes, ma'am. Yes, ma'am.
dear. See, first of all, it's my kind request to join on time. How much time we have to waste, on recapitulation and all. This way, some students are missing something, some other are missing some other thing. So, no use, no. We have to make use of these 40 minutes.
Ma'am, can I answer?
Yes, Siddhant.
Ma'am, like we can also say vehicle mirrors.
Vehicle mirrors, very good. Hamza,
Ma'am, ophthalmoscopes.
pardon?
Ophthalmoscopes.
Can you please write in the chat? I cannot hear you.
Ma'am, can I?
Hmm.
Ma'am, they are used in the concave mirror are used in headlights, like the reflectors of a car.
Great. Good answers. I want response from everyone. So please do.
Ma'am, can I tell? Ma'am, I posted my answer in chat.
I want to give the chance to everyone. So those who have already answered, please stay calm for some time. Charvik, ophthalmoscopes. Okay, fine.
Ma'am, can I tell?
Who was this? No, wait. Soumya? Manas?
Camera lens, ma'am.
Pardon?
Camera lens, ma'am.
Camera lens. Okay, that is actually a lens. Fine. We are here discussing about the mirrors, right? But it's okay. So let me tell you more about spherical mirrors. What are those? How they are carved out and how they are made, etc. Siddharth and Divesh, you have raised your hand. Was this to answer that same question only?
Yes, ma'am.
Okay, it's okay. Now we are moving ahead. Okay. Please share the screen. A real life example I already gave you. If you take a spoon, the front side which we use to eat is curved inwards. So any surface curved inwards is known as concave. Okay. But when the mirror has that inner curved surface, then we call it concave mirror. On other hand, when we reverse our spoon and see the back side, it is curved outwards, right? You can take the actual spoon or you can just understand it with your help of your back side of your palm. So curved outward surface means convex. And when that convex surface is in case of a mirror, we say it is a convex mirror. How these are made out? Just tell me. Now you have to imagine a ball. Like I hope all of you plays with football or basketball, and you all know that these are hollow in nature, isn't it?
Yes, ma'am.
You understand the meaning of hollow? Hmm? Now
Yes.
that we have a surface which is hollow, and the surface inward is all made of a mirror, and the outside surface is all painted. Imagine the ball like this. The inner surface is a mirror and outward surface is painted. Okay, we have to carve out a little piece from this ball, let's say this part only, and I have kept this part this way. I have kept this part like it seems like a ball which do not have a great depth but a lighter depth. Okay, so the outward surface will be painted. I'm making it with the I'm making it this way, the dotted sides. Okay, and the other inward surface is a mirror. So this mirror will be a concave mirror. Got it? How these are made out? These are actually
Yes, ma'am.
carved out of these surfaces. You can imagine like this. Okay. This is a concave mirror. On other hand, now imagine that the same hollow ball is now painted from inside. Inside surface is painted and this outside surface is made up of mirror. Now we have to carve out this portion and I'm keeping it like this. Not so deep means not a very light curve. Okay. So the inside surface is painted as you can see here. And the bulged out surface here is mirror. So such type of mirror is known as convex mirror.
Ma'am, the curved out one is convex.
Curved outward is convex and curved inward is concave.
Ma'am, so like concave will like show like the opposite of lateral inverted, like it's vertically inverted.
Vertical inversion, yeah. Good, you noticed it. This chapter is, very interesting. If you actually perform and experiments are also very simple. You can do it at home itself. So please draw it.
Ma'am.
Should I clear it out?
Ma'am,
Yes.
does magnifying glass use the spherical mirror?
Magnifying glass. That glass, you see the things that are on the other side, right? So first of all, it is a glass, but it is not a mirror. It is a lens, which is also spherical in nature. I'll tell you about that also.
Like
And
it is concave and convex.
sorry.
So like it is carved this way.
No. That is dear. That is a lens. Means it do not have any painted surface. We can see through the lens, isn't it? That is used to read the letters. That
Yes,
is used
ma'am.
for reading purpose, right? So that is not a mirror. It's a lens.
Okay, ma'am.
Ma'am, should we draw this ball?
Yeah. For understanding, it will be great. Means you
Okay,
can
ma'am.
easily understand.
Done.
Just in the bracket, write one more thing. Curved inwards means concave mirror. In concave mirror, the mirrored side is curved inwards, and in convex mirror, it is curved outwards or bulged out. Should I clear it?
Yes, I'm done.
All of you?
Ma'am, one minute. Done, ma'am.
Okay.
Done, ma'am.
Now we learn about a few parameters that plays a vital role in deciding that where the image will be obtained in spherical mirrors, and if we move away, if we move towards it, what will be the change in the image, right? So those parameters play a role that way. Now imagine again, now we are talking only about the concave mirror. Okay, please excuse me that I'm not able to draw the perfect circles on this because it's a pentab. Like imagine this is a sphere again, and I'm going to carve out a concave mirror out of it. So like every circle and every sphere has a center. This ball will also have a center point. Okay. And if I draw it, if I join it with the point on the circumference, this is known as a radius. Is it fine?
Yes, sir.
Okay. Now I'm taking out this much piece on the right hand side as my mirror, concave mirror. I have taken it out. Now, because I have carved out this piece already, it doesn't mean that it do not have a sphere. Very simple. If I complete this circle, like I'm drawing it dotted because this is not actually present here. I'm just imagining, okay? Then also I can clearly draw its center point. So every mirror has a center point, irrespective that it is no more a sphere. Now, any means whatever area, or you can say whatever size I have carved out, this is known as the aperture of mirror. The size of mirror that I have carved out is known as aperture of mirror. Is it fine?
Yes.
Means overall
Yes,
area
ma'am.
from which if I throw a beam of light on this side, on the mirror side, the whole piece of mirror will reflect the light. So that whole area is my aperture. Okay. Now, the center point of this surface is known as pole, denoted by capital P. This was a center point denoted by capital C. Now, if I join this line from center to the pole, isn't it the same, the one I have drawn here, like the radius of
Yes, sir.
circle? This is
Yes,
the,
sir.
so here also, this will be the radius of this mirror. Okay. Center, this is known as center of curvature. Just in case of mirror, we say center of curvature. P stands for pole. This is aperture. Now, it is a special property of concave mirror, especially that if I throw a beam of light from infinite distance, uh, can you tell me any source which
Ma'am,
light
torch.
at distance and which has its own light?
Ma'am, like, I don't
Ma'am,
know an
torch.
example, like, which has its own light. But actually, this can be a doubt also when we take any spectacles. Now, if you take one spectacles
Now, why do we wear spectacles? To protect us from blue rays. So, rays are also a part of light, right? So, when the rays touch the mirror of our spectacles, it bounces back. Like blue ray spectacles, like that, kind of. So, it bounces back to light, right? So, isn't it a concave mirror?
Ma'am, like actually specs makes us see clear. So is it?
At some point, I missed your point. I'm so sorry. Can you please write your doubt in the chat?
Okay, ma'am.
Yeah, okay. I'm telling you that the sun we can consider as a light source lying at an infinite distance. Okay. Oh, you can take a torch also, keep it a much farther distance. It can be considered infinite. It should be, 3 to 4 times bigger than the size of your mirror. It will become infinite. Okay. So this is a property of concave mirror that if we allow a parallel beam, sorry, any light rays coming from infinite distance would be considered parallel because they are coming from far away distance. Okay, so any parallel rays of light are allowed to fall on the concave mirror. I forgot to make it dotted dash on the right side because it is painted. Please remember to do that. On the right side is painted. Okay, now all those parallel light rays will converge at a single point. Can you see? And that is the same axis. The first of all, the axis from center of curvature to pole is known as principal axis. Please note it down. I'm writing in short. You can write the whole statement. The line joining from C to P is known as principal axis.
Ma'am, I sent it my doubt in the chat.
Ma'am,
Okay.
can you repeat it once again?
Pardon?
Can you please repeat it? Like, what is it?
The line joining the center of curvature and pole is known as the principal axis. So I mean this ray is principal axis. Let me draw it with other color.
Oh, okay, ma'am.
This is principal axis. Okay.
Ma'am, can you write it down? The statement.
So this is a property of a concave mirror that whenever parallel light rays will fall upon the mirror, all the light rays will meet at the same particular point. And very means I should say something very great more than this is the point where they meet. Let's say they are meeting at point capital F. I'm naming it capital F. That capital F is exactly the half of the radius. Color has become so light. That distance, if I say exactly lies in between the C and P, means it is the half of radius of curvature, radius. Okay. So this point where they are meeting is known as the principal focus. Please mark capital F as principal focus. And the distance, like from C to pole, is radius. If I measure the distance from F to P, this is known as small f, which is focal length. I know few of you must be wondering, this is not, mentioned in our NCERT. Then what is this? I wanted to tell you something more than what mentioned in your NCERT. You will like it.
Ma'am, select
Ma'am, then what textbook is this from?
Sorry?
Ma'am, if it is not from NCERT, where is it from?
This is something extra. It is not in some other book. It is not up to the level of 7, little higher level.
Okay, ma'am.
You are soon going to study it in your higher classes. Let me summarize. We have C, center of curvature. The distance from C to P is radius of curvature. Then we
Ma'am,
got
can you clear my doubt?
point F, which is the principal focus. The distance from F to P, this is denoted by small r radius, and F to P is a focal length, which is denoted by small f. What else? Aperture is already here. This PA, you can write principal axis. You have already written the definition. I hope all of you have written principal axis.
Ma'am, I'm writing.
Okay. That's it. Enough. Not more than this, I'll tell you. Okay.
Ma'am, can you like say the exact definition, like in a sentence, the definition of principal focus and focal length?
Okay. First tell me, is it clear by the diagram that what is it? Is it clear by the diagram?
No, ma'am.
Uh,
Not that much, ma'am.
okay. Now you do one thing, that you do not take a mirror. You imagine that it is still a sphere, but because it is actually not a sphere, so I'm drawing it dotted. Okay. Now this part only is my mirror. The outside surface is painted. The center point of the sphere will be center of curvature. This intersection, the center point of the mirror is pole, capital P. The whole surface is radius of curvature. If I allow the parallel light rays to fall upon mirror, they will meet at a common point, which is known as a principal focus, because all the rays are focusing at the same point. This distance is R, and principal focus to pole is focal length.
Ma'am, so C is center of curvature.
Yes, yes. Like every sphere have a center, this mirror also has a center. Clear? See, because this is already little higher in level from class 7. So I don't want you to get, so much in detail. Just understand with the help of diagram. Because I need to explain you why this is known as principal focus. Once you will perform the experiment, you will see that, if you hold a concave mirror in front of sun, right? And suppose sun is here in front of my eyes. Here is my concave mirror, and like at distance of some 15 to 20 centimeter, I hold a paper or a screen or a wall, anything. I will find that a sharp, very bright image of sun will be obtained on that paper, because concave mirror forms a real image. So that point will be focus point only, principal focus. Why? Because infinite light rays are striking the mirror and they are focusing it at a point, which is the principal focus.
Okay, ma'am.
Understood?
Yes, ma'am.
Yes, ma'am.
So if you have noted down all this, not more than this, I'll clear it out and we'll come back to the same level. Should I clear it? Should I clear it, everyone? Please tell.
Ma'am, 1 minute.
I'm right.
I'm writing.
Ma'am, can you explain me the doubt that I sent in the chat? Like once you explain that, I have another doubt from that only.
I didn't get it. Please repeat.
Ma'am, I sent it out in the chat.
Okay. Just looking. Dear, in magnifying glass, this is not used, Rohini, because that glass is not a mirror, that is a lens. There is no painted
Ma'am,
surface.
ma'am, this the diagram which you made, that is concave mirror, right?
Concave, yeah.
Okay. Ma'am, what about convex mirror? How will,
What about?
ma'am, how will convex mirror be?
We'll come to convex mirror also first. Give me a green signal to erase and move ahead.
Okay, ma'am.
Ma'am, you can erase it.
Done, everyone? Should I clear it?
Ma'am, I'm right.
Yes, ma'am.
Ma'am, still writing.
Ma'am, can you explain the doubt?
Also, spectacle zero is when it touches the middle of the spectacle, the rays bounce back, there are some rays remain. Then, is it a concave or convex spectacle shower glasses? Okay. In spectacles, we have both, again, that is not a mirror. The spectacles are lenses. Okay. And yes, because you have mentioned that some rays bounce back. So this is the case with the lenses also, that some rays may bounce back and more of that will refract, means pass through. So all the spectacles are not mirror. None of the spectacles are mirror. All of them are lenses.
Ma'am, so like at the torch's outer glass, is that concave?
The glass, yeah, is a normal glass. That is not a okay.
Ma'am, is it,
You
ma'am,
are
I-
getting
ma'am, is it
confused
like
if
this?
the mirrors have a used in torches and headlights, where it is used in the means in the front side of the bulb or the back side of bulb. You are confused there, I guess. Is it
Ma'am,
so?
ma'am, is this a concave mirror? I'm showing it in camera.
You note it down fast. I'm also eager to explain something to you. My applications.
Ma'am,
I'm
I'm showing. Ma'am, is this a
clearing it out.
concave mirror?
I'm clearing it out.
Ma'am, 1 second.
Ma'am, is this a concave mirror?
Yes, this is a concave mirror.
Okay, ma'am.
Be attentive, everyone, please. Please read this. Concave mirror is also known as a converging mirror. Any idea why this is known as a converging mirror? Because the diagram which I have just drawn, all the parallel rays coming from infinite distance were focusing at a single point. And the phenomenon of, meeting at a single point of focusing is known as converging. The word converging means meeting at a single point. Okay, this is why this is known as converging mirror. So the mirror whose reflecting surface is concave and polished surface is convex, this is called concave mirror. It reflects the parallel rays of light in such a way after reflection that all the rays converge at one point, and that one point is called the focus or principal focus. Okay. Since a concave mirror converges a beam of parallel light rays, therefore it is also known as a converging mirror. Is this clear?
Ma'am, should we write this?
No, not now. Later on, please. This I'll be uploading, so don't worry to write. Only understand.
Okay, ma'am.
Ma'am, will you upload it in the Visa?
Yeah, I upload. Yes, please check. After every class, I upload whatever I've taught. But just whatever I'm explaining, because every single thing cannot be written in this notes also. So whatever I explain apart from this, that you need to write in your own words or anyway.
Okay, ma'am.
Next is when the object now. There are several cases. See, in the concave, in the concave mirror, we have a pole here, we have center of curvature here, we have principal focus here. Now our object can be kept at infinite distance. Please note this thing, okay? This is infinite. Now, after this, if I bring my object little near to the mirror, I can bring it like beyond C. Means last parameter I know related to the mirror is C. So I have brought it into my finite distance, but it is beyond C. I can bring it to C also. Then I can bring it in somewhere in between C and F. Then I can bring it at F. Then I can bring it in between F and P, and then means not more distance. Okay. Why I'm telling you this? Because as we bring our object near to the mirror, the image in the mirror changes. The size changes. The way we approach the mirror, there is some other way that our image is approaching the mirror. That's why I'm telling you. Now, in all these cases, from infinity to the point when the object is at focus point. You can say not till here, wait. From infinite distance to a point just before focus, the image formed is real and inverted. Means if your object is anywhere from infinite distance to this distance before F, you will not see the image in the mirror like we do in the plane mirror. The image will not be visible inside the mirror. Then where it is? It is formed somewhere here only. So you have to keep a wall, means you have to stand in front of a wall, make your wall as your screen, make a curtain, hold a piece of paper, hold anything and try to move it here and there. You will find at some point the image will definitely be obtained. What happens when the object is kept at F? You know, this is again one of the nice property of this concave mirror, that if we keep any of the object at F focus point, all the light rays that are striking the mirror from the focus, light rays striking the focus after reflection from mirror, they will go straight back and parallel to principal axis. So you can say this property is just the reverse, the reciprocal of the property of the first property I told you, that when all the infinite distance right the mirror,
Ma'am, I have a doubt.
and when any of the object is kept at focus, suppose you keep a bulb at focus. Okay, imagine I have fixed a bulb here at focus point only. The bulb is lying at focus. Now all the light rays will emanate, and after striking the mirror, they will go straight far away to infinite distance. So are you getting a use of concave mirror from this property? I'm
Yes,
giving
ma'am.
yes, tell me. By this diagram, I am straight giving you the hint of one of the use of mirror that you all have already used. I think so.
They can be used as reflectors.
Reflectors, very good. Searchlights, torch,
Torch.
getting it? So you can say that a torch is this way. So where we have the handle of torch, this is a glass, this is a covering glass, just the normal covering glass, and this is our handle of torch. This way the torch is made. Are you getting an idea? Although it is a very rough diagram, it's clear. Okay.
Yes, ma'am.
Ma'am, we could just go to Google and show an image of torch.
Speak loudly, please.
Ma'am, we could just go to Google and find an image of torch, and you could explain us.
You can do it, but I hope this is, if this is clear, that's what you do.
Ma'am, I have a doubt.
Then I'm supposed to draw the proper diagram of torch.
Ma'am, I have a doubt.
Yes.
Ma'am, my doubt is like how we'll know that where is the center point of the concave mirror?
Where the
Center point, ma'am. Center point of convection.
this you need to find out by an experiment. I'll just tell you. Okay.
Okay, ma'am.
So torch, the place where the bulb is fixed, just behind the bulb we have here concave mirror. So if you want to draw this diagram, draw this also, please. Just draw a mirror, that white part only. A normal bulb, this is for understanding that this is a bulb here. Otherwise, you can just draw a dot and write F. Means anything kept at the focus point, the rays coming out from that will, after reflection, that will pass straight parallel to principal axis, farther away. So the use of concave mirrors are searchlights, torch, and one more case I was supposed to tell you. That I'll tell you in the next class because the time is over. So please just remind me in the next class that one of the cases left in concave mirror. The last case, tell me, okay?
Okay.
Draw on this.
Ma'am, 1 minute.
Be quick.
Done, ma'am.
Done, ma'am.
Done. Okay.
Done, ma'am.
Okay. Please revise. Because today we have a lot of discussion on the mirror. Revise everything. I'll be
Okay.
asking that in the next class.
Okay.
Fine. Okay. Bye-bye, everyone.
Okay. Bye. Yeah.
Bye, ma'am.
Bye, ma'am.
Bye, ma'am. Thank you, ma'am. Bye, ma'am.